In the previous video, we derived the formula of one of the compound angles, correct? The formula what we derived in the last video was cos of x plus y is equal to cos x cos y minus sin x sin y. This is the formula. Now, using this formula, we'll calculate other compound angles, other trigonometric compound angles, you can say. Fine. Now, the very first one, what we are trying to derive using this one, that is cos of x minus y. Now, very easy. Wherever you have y, you put minus y. Because cos of x minus y can also be written as x plus of minus y, correct? That means here what we are trying to do. So, we can write this as x plus of minus y. It's the same, isn't it? Now, you're going to write cos x into cos of minus y minus sin x into sin of minus y. Cos of minus y is cos y and sin of minus y is minus sin y, isn't it? So what we end up is we are going to end up with cos of x minus y is equal to cos x cos y plus sin x sin y. This is going to be the next formula, cos of x minus y. This is another compound angle formula. Say for example, they'll ask you, find cos 15 degree. Then we'll use this one. Okay. Or say sine 30 degree. Sorry, not sine 15 degree. For those things, we are going to use sine function. Fair enough? Now, this is one of the compound angles. Now we'll go for sine of x plus y and sine of x minus y. Sine of x plus y. See, this we can write it as cos of 90 minus of x plus y. Sin theta is cos of 90 minus theta, correct? Or sine of pi by, cos of pi by 2 minus theta. Now in this case, what we can use, see here, what we'll do, we'll take this as some value capital letter x, we'll take this as capital letter y. That means we have cos of x minus y, correct? We just derived cos of x minus y. That means we are going to take cos of capital X minus capital Y is equal to cos X cos Y plus sin X sin Y, correct? So in this case, cos of X, so that means cos of, what is the value of X? 90 or pi by 2, right? So cos pi by 2 into cos of X plus Y plus sin pi by 2 into sine of x plus y. Correct? This is what we have. Now, cos pi by 2 is 0. So, we are not going to do anything for this one. And sine pi by 2 is going to be 1. Right? So, we end up with sine of x plus y itself. No change. But what we can do here is we have to get the value of sine of x plus y, isn't it? So, for this, the grouping of the sine of this cos of 90 minus x plus y is going to be a little bit different. Here, I showed you this particular method to understand how grouping of terms can be done. Okay, grouping of terms is very important, especially in this one. Now, when we have sine of x plus y, which is cos of 90 minus this one. Now, what you do, we are going to take it in a different way, a bit different way. That means cos of 90 minus of x plus y. Now, this we can write it as cos of 90 minus x, this is 1 minus y. Correct? The same thing. Very similar formula. Now, if you apply the formula, the same thing, cos of x minus y types, whatever we did before, we are going to get, this will be equal to cos of 90 minus x into cos y plus sine of 90 minus x into sine y. What is cos of 90 minus x? Sin x. You get sin x cos y plus cos x sin y. This becomes sine of x plus y. So the formula is going to be this. Sine of x plus y is this, sin x cos y plus cos x sin y. Now same thing we'll do for sine of x minus y. Alright. Sine of x minus y. Now here we can write this as sine of x plus of minus y. Correct? The same thing what we did before. So this is going to be sin x cos of minus y plus cos x into sine of minus y. This is going to become sin x cos y minus, because plus into minus is minus, minus cos x sin y. So sine of x minus y is going to be this. So the formula is going to be this one. This is sine of x minus y. Now we have four formulas: cos of x plus y, x minus y, sine of x plus y, sine of x minus y. Now we'll do the same thing for tan of x plus y and tan of x minus y. All of you know that tan theta is nothing but sine theta by cos theta, correct? Same thing, tan of x plus y will be sine of x plus y divided by cos of x plus y. Clear? So tan of x plus y, this is going to become sine of x plus y divided by cos of x plus y. Alright, this is going to become sin x cos y plus cos x sin y whole over cos x cos y minus sin x sin y. Right? Now what we do is we divide both numerator and denominator by cos x cos y. Okay, so what we mean by cos x cos y is we are going to divide both numerator and denominator by this particular value, cos x cos y. Fine. Once we do that, now you are going to get sin x cos y divided by cos x cos y plus cos x sin y by cos x cos y whole over 1, this divided by this, minus sin x sin y divided by cos x cos y. Now what gets cancelled here? Cos y gets cancelled, and here you're going to have cos x, which is going to get cancelled. Well, now what do you get? Sin x by cos x, tan x, plus sin y by cos y, tan y, isn't it? So you're going to have tan x plus tan y, correct, divided by 1 minus, what is sin x by cos x? Tan x into tan y. Tan x into tan y. So the result tan of x plus y is going to be this, tan x plus tan y by 1 minus tan x tan y. This is the formula for tan of x plus y. Say for example, they'll ask you what is tan 75. Then take x as maybe this one 45 and y as 30. Apply the formula. Okay, or you can also do 60 plus 15. If you know 15, you can do it though. Otherwise, you can just use this form. Alright, you have one more formula, tan of x minus y. It's the same thing. Wherever you have y, put minus y and you will get the answer. Okay, so we'll do the derivation now. Tan of x minus y, this is going to become tan x plus tan of minus y divided by 1 minus tan x into tan of minus y. Okay, this is going to become tan x minus tan y plus of minus. Do you remember tan of minus theta is minus tan theta, right? Divided by 1 plus tan x into tan y. This is going to be tan of x minus y. So the final answer is going to be this. This is tan of x minus y. Now we are going to use this formula quite a lot, especially when it comes to straight lines. The angle between straight lines, we use this particular formula, tan of x minus y. All right. Now all these are standard compound angle results. Now apart from this, we also have cot of x plus y and cot of x minus y, which basically is just reciprocal of this one. Okay, when you take cot of x plus y, then you will get 1 minus cot x cot y by cot x plus cot y. Fine. When you have cot of x minus y, then you will get 1 plus cot x cot y by cot x minus cot y. Fine. Now, whatever the result we have derived so far, we have derived 6 results, right? Cos 2 formulas, sin 2 formulas, tan 2 formulas. And if you take cot also, then 8. We'll just list out all the formulas so that you will remember them. The first formula is based out of cos, correct? So the first one, cos of x plus y. This is going to be cos x into cos y minus sin x into sin y. First one. Second formula, cos of x minus y. This is cos x cos y plus sin x into sin y. Second formula. The two formulas based on cosine. Next, we have two formulas based out of sine function. That is, when you have sine of x plus y, you have sin x cos y plus cos x sin y. And when you take sine of x minus y, you have sin x cos y minus cos x into sin y. Right? Then we have tan function. That is, when you take tan of x plus y, this is tan x plus tan y divided by 1 minus tan x into tan y. And the next one is tan of x minus y. This is going to be tan x minus tan y divided by 1 plus tan x into tan y. Now, these 6 trigonometric functions are quite important. To calculate multiple angles, submultiple, whatever it is, this is very, very important. Okay. Now, I'll show you for cot, two formulas, no derivation, just I'll give you the formula. Then using this, how we get the allied angles? One or two examples I'll show. All right. Now, for cot, when we have cot of x plus y, you get cot x into cot y minus 1 divided by cot x plus cot y. This is one formula. And when you have cot of x minus y, you get cot x into cot y plus 1 divided by cot y minus cot x. That's the second formula. So we have two formulas in cot. Now I'll show you a couple of examples based on allied angles. Say for example, we are doing sine of 270 plus theta. What are we going to get? Something like this. Few examples will do. Say you have, let's say cos of pi by 2 plus theta. Now cos of pi by 2 plus comes in second quadrant. Second quadrant cosine is negative. We know it's going to be minus sine theta. But let's apply the formula and let's try to do it. What is cos of x plus y? Cos x cos y minus sin x sin y, right? So this is going to be cos pi by 2 cos theta minus sine pi by 2 sine theta. What is cos pi by 2? 0. That means this entire term becomes 0. Sine pi by 2 is 1. So you get cos of pi by 2 plus theta is equal to minus sine theta. See, easily we'll get the value. Let's do the same thing for pi, pi plus or 2 pi minus. Okay. Suppose say you have sine of say pi plus theta, third quadrant. Sine of a plus b or sine of x plus y is what? Sine x cos y plus cos x sine y. So we get sine x sine pi cos theta plus cos pi into sine theta. What is sine pi? Sine pi is 0. That means this entire term is 0. Cos pi is what? Minus 1. So you get sine of pi plus theta is going to be minus sine theta. See? Get the same value. So all the allied angle values we can calculate with the help of this one. Fair enough? Now, all the major ones are this was 6 one. Then you have the cot 2 functions. Remember, compound angles are extremely important. Now, go through the video one more time so that you would remember all the formulas. Alright, so with the help of these compound angles, we can also calculate the value of all the allied angles. Alright, so in the next video onwards, we'll do multiple and submultiple angles.